Welcome students. In this video, let us try to have a basic understanding of inverse trigonometric functions. The first question that we are going to deal with is, what are inverse trigonometric functions? In the previous module of functions, we have already seen what an inverse function is. So if f of x is a function, f inverse of x is a function which satisfies the condition f inverse of f of x is equal to x and f of f inverse x is equal to x. That is, so if f connects an element x in the domain to an element y in the codomain, f inverse is defined from the codomain of f to the domain of f, and it brings back y to x. This is the definition of inverse function. As the name suggests, inverse trigonometric functions are inverses of trigonometric functions. We know that you have 6 trigonometric functions: sin x, cos x, tan x, cot x, cosecant x, and secant x. So what we are going to learn are the inverses of these functions. So we usually denote it by sine inverse of x. Sine inverse of x is the inverse of sin x. Cos inverse x, this is not equal to 1 by sin x. This power minus 1 does not imply what it implies in the chapter of exponents. So usually in the chapter of exponents, a power minus 1 is 1 by a in the chapter of exponents. But in the chapter of functions, power minus 1 denotes the inverse function, not the reciprocal function. Similarly, you have functions tan inverse x, cot inverse x, cosecant inverse x, secant inverse x. These are the inverse functions to the trigonometric functions. Now, what is so special about inverse trigonometric functions? The specialty is that these inverse functions cannot be defined for complete function of sin x, because we have already seen that inverse functions exist only for bijective functions. Inverse will be defined only for 1, 1 onto functions. Now, are trigonometric functions 1, 1 onto? No, right? These trigonometric functions are periodic functions. Means a particular value goes on happening again and again after a certain interval. So, sin x, cos x, tan x, cot x, cosecant x, and secant x are not bijective functions. So, to define the inverse, first we need to restrict the domain and the codomain so that the functions become bijective, and within that domain and range, we'll have to define the inverse of the function. So we have already seen that a function can be made into a bijective function by appropriate restriction of domain and codomain. So for example, so if f of x is equal to sin x, if this function is defined from real numbers to real numbers, this is not a 1, 1 onto function. So first let us try to understand the domain restriction under which these functions become 1, 1 and onto. Let us first take graphs of y is equal to sin x and y is equal to cos x. So this is f of x or y is equal to sin x is the graph, as you know, and the second is the graph of cos x. So if these functions are defined from real numbers to real numbers, obviously these are not one-one onto functions. So first, let us make this function into an onto function. So how do you make the functions into onto function? By appropriate restriction of codomain. We know that the range of sin x and cos x is -1 to 1. So I'll make the range equal to the codomain. So first I'll define these functions from real numbers to -1 to 1. So if I do this restriction of codomain, now the codomain is equal to the range of the function, hence this function has, both these functions have become onto functions. But if the domain is real numbers, the 1-1 nature is being not satisfied, because corresponding to a particular y, if you draw a horizontal line, it cuts the curve at many points. For a 1-1 function, it has to cut at 1 or 0 points. So first what we do is, we try to restrict the domain. So we have seen that there are different ways in which domain can be restricted. So what we are doing now is the standard restriction, which everyone will do. All the mathematicians have agreed upon. So the restriction for the function sin x is -π/2 to π/2. So I'll restrict the domain to -π/2 to π/2 and the codomain to -1 to 1. So within this domain and within this range -1 to 1, so you have only this part of the graph, this part of the graph. So this part of the graph is a 1-1 onto function, hence this is a bijective function. So only for this part of the graph we define the inverse function. So what is the restriction of domain? -π/2 to π/2. What is the restriction of range? -1 to 1. So within this domain and codomain, the function sin x becomes a 1-1 onto function, and sin inverse of x is the inverse of this part of the function. Similarly, if you take the function cos x is also not 1-1 onto. So for this we restrict the domain and codomain like this. The domain is restricted to 0 to pi, because for cos x -π/2 to π/2 does not work. So between -π/2 to π/2, cos x is not 1-1. So we restrict the domain to 0 to pi. So we take this graph. We take this part of the graph from 0 to pi, from -1 to +1. So the domain is 0 to pi and the range is -1 to 1. So for different functions, you have different restrictions. For sine, -π/2 to π/2 and -1 to 1. For cos, 0 to pi and -1 to 1. So let us look at the further restrictions for the other functions. So next, for the functions tan x, cot x, cosecant x, secant x, also we do appropriate restriction of domain and range. So for tan x, we take the domain from open -π/2 to π/2. So tan x defined in open -π/2 to π/2, and the range is from -∞ to infinity. It is all real numbers. Similarly, for cot x, the restriction is between 0 to pi. So if you take one arm of cot x, it is both 1-1 and 1-2. So the restriction for cot x is from 0 to pi, open 0 to pi, because cot is not defined in 0 and pi, to all real numbers. And for the function cosecant x, so cosecant x is not defined where sine is equal to 0. So we take half arm here and half arm here. So we take these two arms, and with respect to these two arms, cosecant x is 1, 1 and odd. So the domain is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2 closed except 0, because at 0 it is not defined, and the range is from minus infinity to minus 1, minus infinity to minus 1, union 1 comma infinity. So within this domain, minus pi by 2 to pi by 2 except 0, and codomain minus infinity to minus 1 and 1 to infinity. The function is bijective. For secant x, we take half of this arm and half of this arm. So the domain is close at 0 to pi except pi by 2, and the range is again the same as cosecant. So these are the restrictions of the domain and range for the trigonometric functions under which the inverse can be defined. So the functions sine inverse, cos inverse, so on are inverses of the trigonometric functions only within those domains and codomains. So this is what you need to understand clearly.